Hey guys, welcome to our senior secondary physics series. In this video, we're going to take a look at a topic called motion. In some books, it's called speed, velocity, and acceleration, or maybe you might know it as equations of motion. But in this video, we're going to call it motion. So let's get started. First thing first, to start with a topic map. So we're going to start with properties of motion. So motion is movement. So we're going to study how objects in the physical world move from one point to A. So properties of motion, we're going to study the properties of movement. What are the things you need to know about things that are moving? So that's what we'll start with. Once we start properties of motion, we're going to take a look at uniformly accelerated motion. Uniformly accelerated motion. So it's a special type of motion. Don't worry about the words that you don't understand here, because they will become clear soon. From uniformly accelerated motion, we're going to take a look at a very special type of motion called free fall. This is an interesting thing to study. You'll see it's nice. Free fall. Once we're done with free fall, we're going to take a look at graphs of motion. So this will be the last subtopic, graphs of motion. So the first two properties we're going to take a look at are distance and displacement. We'll start with distance. So whenever there's motion, whenever there's movement, when something in the physical world moves from point A to point B, then distance has been covered. So distance is defined as the total length taken between 2 points. Its units are meters, and when it comes to the types of quantities, either vector or scalar, it's a scalar quantity because it doesn't care about the direction. Distance is distance. So let's say we have a gyra here and it moves from here to here. This length it covers is what distance is. I'm sure we all know what this is. But anyway, since we are learning, so we just have to share the common points that must be taken note of. The next property of motion we're going to analyze is displacement. What is displacement? Displacement is defined as the total length taken between 2 points in a specified direction. If you look close, you'll see that this is the definition for distance, but with some words added. The words are in a specified direction. Therefore, displacement is just distance in a specified direction. The units for distance and displacement are the same, which are meters. However, displacement is a vector quantity, while distance is a scalar quantity. To analyze visually the difference between displacement and distance, we're going to use this motion here. So let's say this car moves from here to here. Let's say it has covered a distance of 20 meters. Then its displacement can be stated as 20 meters east, because displacement, you have to state the direction or to specify the direction. Let's say it turns and goes back. Let's say this time it reaches here, it doesn't reach where it was at first, and it has covered, let's say, a distance of 15 meters. Its displacement will be stated as 15 meters west. So the directions that can be used are words like west, east, north, south, left, right, down, up, like that, so long as it gives someone that idea of direction. So sometimes it is required of us to state the total distance and the total displacement such a motion had covered. So total distance, you get it by adding all the distances that were covered regardless of direction. Why? Because distance doesn't care about direction. So we can say total distance is 20 meters plus 15 meters, which will give us 35 meters. What about displacement? Well, displacement cares about direction. So for us to state the displacement that was covered, we'll go back to where the car was. So total displacement is, so go back where the car was. So initially the car was here. So we'll ask ourselves, how far is the car from here? So this distance here might be 5 meters, because if it had gone east 20 meters, then coming back it had only covered 15 meters, which means the remaining distance for it to reach where it was before, it is just 5 meters. In short, it's just 20 minus 15. So that's our total displacement, 20 minus 15, which is equal to 5 meters east. So that's how to, and note that I've added east. Why? Because from where the starting point is, the direction where the car is to the east. So that's how to that's how to state displacement. So let's analyze the last example here. So I've got a circular path here, or a road which is making a circle, like on a roundabout. So let's say we've got an object here and it moves like this. So we can see that where it is now is the same position it was before. Let's say the length or the circumference of this path is 25 meters. Circumference means the length around the circle or around a circular path. So the question is, what is distance or what is displacement? Let's start with distance. So the distance is just the length around the circle. It doesn't care about direction. It's just the total length it covered, which is 25 meters. What about displacement? So displacement cares about direction. For you to know the displacement, you have to go where the object was at the start of the journey and ask yourself, what is the length between this point and the point where the object currently is? And of course, you have to consider the direction. So in this case, we can see that it is still at the same position as it was when the journey started, meaning that the length is 0 meters. Therefore, our displacement is 0 meters. But the question is, in which direction? So you can state any direction, it doesn't matter, because 0 meters, it means it never moved to any of the directions. So even if you say 0 meters east, it's just the same as 0 meters west, 0 meters south. So that's how that's how we get the displacement. So the displacement is 0 meters. You can add whatever direction you want, but you have to show that it hasn't moved, and you do that by the 0 meter that you put. So this is the last example on distance and displacement. The next property we're going to take a look at is speed. What is speed? So speed is the change of distance per unit time. What this means is, given a specific amount of time, let's say 1 second, how much distance does a moving object covers? That's what speed is. Let's say we have got two objects that are moving. Then in 1 second, one has covered 5 meters. Then the other one has covered 1 meter. So which one is fast? The one that has covered a lot of distance in a shorter time. Hope you can visualize what I'm saying, but I'll give you a demonstration, don't worry. So the formula for speed is distance over time. In case you forget the definition of speed, you can just recall the formula. The over is also read as per. So you can say speed is equal to distance per time. And if you want to define it, you can define it as speed is the change of distance per unit time. So here's the demonstration. We've got two Jiras here, and we've got a finish line there. So which one is faster? So let's do, as we used to say in Nyanja, maspokes. So we can see that the bottom one was faster than the one on top. What this means is, in a short time, the one on bottom had covered a lot of distance than the one on top. Try to think about that. It's very important. So the units for speed are meters per second. So when we were doing introduction to physics, I did not encourage the mastering of derived units, because if you have forgotten that the units for speed are meters per second, you can just see that you can just remember the formula when you are solving distance over time. The units of distance are meters and the units of time are seconds. And I've said this over is also the stroke or the pay. So distance over time, which is just the same as meters over seconds or meters per second. So that's where the units are coming from. The units are coming from the formula. So just from the formula, you can be able to tell what the units are. So what type of quantity is speed? Speed doesn't care about direction. It's like distance. And even in its formula, it uses distance, which is a scale, and time is a scale. So we just have things that don't care about direction. So speed is also a scalar quantity. So let's take a look at an example. So an example says a car moved from point A to B in 2 seconds. given that the distance the car covered was 10 meters, what was its speed? So it moved from A to B in just 2 seconds, and they have given us the distance it covered. So we can tell what the speed was. So first thing first, let's collect the data from the question. Always when you're solving physics question, it is advisable to collect the data, the numbers you have been given, so that you plan well. So we've first been given the distance, which is 10 meters, and the time, which is 2 seconds. How can we use these two to find or to calculate speed? So we know the formula for speed is distance over time. So we can say speed is equal to 10 meters, which is the distance, and 2 seconds, which is time. Then when we divide, you're going to have 5. And even without mastering the SI units of speed, we can see that the SI units are going to be, or the units are going to be meters per second. So we're going to have 5 meters per second. The pair is that over. So we can say 10 divided by 2, we divide the number, get 5. And for the letters, which is M and S, we're going to just write M divided by S, which is written like that in a cool way. That's how to come up with units if you don't want to be mastering. But of course, if you have mastered the unit for speed, you can just divide the numbers. 10 divided by 2, it's 5 meters per second. So let's take a look at another example, which is the same as the previous example, but with one change. So a car moved from point A to point B in 2 seconds. Given that the distance the car covered was 10 meters, what was its speed in kilometers per hour? So these are the kinds of questions I like to bring during an exam. So the difference between this and that one is they want the speed in kilometers per hour, not in meters per second like the one we got. So how can we do that? So first thing first, let's collect the data. So distance is 10 meters and times 2 seconds, but they want their speed in kilometer per hour, not in meters per second. So this distance has to be converted to kilometers, and this time has to be converted to hours. So we'll do that by like so. 1 kilometer is equal to 1,000 meters. What about x, which we don't know, the kilometer value of this 10 meters, which we want to convert? So the 10 meters we put on the sides with meters, and the x we are going to put it on the sides of kilometers, since it's the one we're looking for, the kilometer value of the 10 meters. So we'll cross multiply, and we're going to get 1000 by x, 1000x, and 1 by 10, it's 10. So it's going to be 1000x is equal to 10. Then we can divide both sides like so, so that we remain with x, and we're going to get x as 0.01 kilometers. So we are now satisfied with the distance, which is in kilometers. What about the time? Let's convert it to hours. So we're going to say 1 hour is equal to 3,600 seconds. What about x hours? We want the one time in hours, so we've put x there. What we're going to get is our answer. And on the second side, we've put 2 seconds, which we have. So we want to convert it to the 2 hours. So we're going to cross multiply. This is 3,600 multiplied by x is 3,600x, and 1 multiplied by 2 is 2. So it's going to be like this. So then we can divide both sides by 3,600, and we're going to have x being equal to 0.00056 hours. So you can use a calculator to get this. Once you have the time value expressed in hours, we can now find what the speed is in kilometer per hour. So I'm going to say the formula speed is equal to distance over time. So speed is equal to, we put the value for distance and time. Distance is 0.01 kilometers and time is 0.00056 hours. And our answer will be, if we punch using a calculator, we're going to get 17.86 kilometer per hour. So I thought of sharing this example because these are the exam type of questions. The next property we're going to take a look at is velocity. What is velocity? So velocity is defined as the change of displacement per unit time. Remember that displacement is defined as distance in a specified direction. Therefore, velocity can be defined as change of distance in a specified direction per unit time. In short, velocity is just speed in a given direction. Just like the way distance is related to displacement, where distance is scalar, and when we add direction, it becomes displacement, so is speed with velocity. Speed is a scalar. When we add direction, it becomes velocity. From the definition, The formula for velocity is equal to displacement over time. So velocity is just you get the displacement of a moving particle, you divide it with time. The units for speed is just the same as the units for velocity, which are meters per second. Like I stated, velocity is a vector quantity, well, speed is a scalar. Let's take a look at this example. So it says, find the velocity of the car below if it took 5 seconds to complete the journey. So what's the velocity? So this is our car. I think we have already studied this. It had covered 20 meters east, then it made a U-turn and covered 15 meters west. So the job was to find the total displacement, which we said is just the difference between the two numbers, or in short, you stand where it had started the journey, then you ask yourself, what's the distance from here to where it is now, which is 5, because for it to reach where it is, it has to travel 5 meters for it to reach 20. So once you know that, okay, the scalar part of the displacement is 5 meters, in which direction? Of course, it is in the eastern direction from where it had started from. So we can say velocity, the formula is displacement over time. Displacement, we have agreed that it's 20 meters minus 15 meters, which is equal to 5 meters east. And time has been given, which is 5 seconds. And you forgive me here because I forgot to to start with data collection, always important. So I was supposed to collect data first. I write time 5 seconds, then displacement, I calculate, or I write 5 meters east, then I start calculating. From here we can say velocity now is 5 meters over 5 seconds. 5 meters, which is the displacement, and 5 seconds, which is the time. So 5 divided by 5 is going to give us 1, and our velocity is going to be 1 meters per second east. So the last property we're going to take a look at is called acceleration, and it is defined as the change of velocity per unit time. What this means is if an object is moving and then the velocity or speed in a specified direction changes from one value to another, that is acceleration. So it can change from a smaller value to a higher value, or from a higher value to a smaller value. That is acceleration. For example, let's observe the movement of this car. So it's moving, it reduces the speed, then it increases the speed. So the moment it reduced the speed and the moment it increased the speed, that's where acceleration happens, which means when it reduced the speed, there was acceleration, and when it increased the speed, there was acceleration. The formula for acceleration is equal to final velocity minus initial velocity over time taken. Final velocity minus initial velocity over time taken. So if a car was moving with a velocity of 20 meters per second, then it increased its velocity to 30 meters per second. The 30 is the final velocity, and the 20 is the initial velocity. We can write this in shorthand like this. A is equal to V minus U over T. So A represents acceleration, V is final velocity, and U is the symbol that has been used to represent initial velocity. Small letter t is for time taken. So be mindful of the way you present your answer. You present your formulas. A is equal to V minus U over T. We're using small letters, not big letters. So these are the standard short ways of representing the formula for acceleration. So if you use, for example, for final velocity, use a big V, and initial velocity, use a big U, that can be problematic because it might mean something else. So for those who are familiar with cars, there is a gear which is called accelerator. So what it does is when you step on it, it increases the speed or the velocity of the car. But does that mean that if the velocity reduces from a higher value to a smaller value, can't we call that as acceleration? It is acceleration, though it is usually called negative acceleration. There is actually a special name that is used to call a negative acceleration. By the way, why is it negative acceleration? So let's say our car was moving with a speed of 30 meters per second, then it reduced the speed to 10 meters per second. If we try to find the acceleration using this formula, our final velocity is the final speed in a given direction, or the velocity it had at the end, which is 10. And the initial is 30, the one it had at first. So it's going to be 10 minus 30, which is going to give you negative 20. So whenever something is reducing speed, the acceleration is going to be negative. So negative acceleration is called retardation or deceleration. So when you hear deceleration or retardation, remember it's acceleration but a negative one. So we can come up with a formula from what we have said so far. So retardation or deceleration is equal to negative acceleration. The units for acceleration are meters per second squared, and the type of quantity that acceleration is a vector quantity. If you forget, remember that acceleration deals with velocity, which is a vector. So even itself is also a vector quantity. So here's an example. A car was moving with a velocity of 2 meters per second before it accelerated to 6 meters per second in 2 seconds. What is its acceleration? What is its acceleration? So first thing first, data collection. So now what have we been given? I've been given initial velocity, which is the velocity it had at first, which is 2 meters per second, and the final velocity, which is 6 meters per second, and the time also 2 seconds. So we recall the formula for acceleration, which is v minus u over t. So we can replace. So acceleration is equal to final velocity 6 minus initial velocity 2 divided by time 2. So 6 minus 2 is going to be 4 divided by 2 is going to be 2 meters per second squared. That's how to get acceleration. The last example we're going to take a look at has to do with finding deceleration or retardation. And the question reads, a car was moving with a velocity of 6 meters per second before it reduced its velocity to 2 meters per second in 2 seconds. What is its retardation? So first thing first, data collection. So let's collect our data. So we have been given the initial velocity 6 meters per second, the final velocity 2 meters per second. Initial velocity is velocity at the start of the observation. So initially the car was moving with a velocity of 6 meters per second. That is the initial velocity. The final velocity is 2 meters per second, and the time taken and for the change in velocity is 2 seconds. So we're going to use these values to get our retardation. But remember, the formula for retardation is given by negative a, where a is acceleration. This means we have to find acceleration first. That's when we can go to retardation. The formula for acceleration, we can recall it's a is equal to v minus u over t. So we can plug in the values. So our acceleration is going to be final velocity, which is 2, minus initial velocity, which is 6, divided by time, which is 2 seconds. 2 minus 6 is going to be negative 4 over 2. Negative 4 over 2 is going to give us negative 2 meters per second squared. Don't forget the units always. Now that we have the acceleration, what is the retardation? So retardation is just the negative of acceleration. So we're going to say retardation is equal to negative. So the value of acceleration that you have found, you put it inside the brackets so that you don't mix up the signs. So the value is negative 2 meters per second. So I've put it in the brackets. And our retardation is 2 meters per second squared. When at some point I thought from definition, since they're saying retardation is negative acceleration, so I thought I used to think that the answer for retardation should be a negative answer, but no, it is a positive answer, provided the speed was reducing. So this marks the end of this subtopic of the topic motion. Make sure you like, subscribe, and share where possible. You can comment in the comment section for clarifications, questions, and anything that you didn't get. we are here for you. Otherwise, happy solving.